So we want to solve a few questions on vectors and matrices and missing values. Let's start with the first question, which is to create a vector temp of temperatures predicted for next week. Here are the values for the vector. There are 5 elements. You copy them and we're going to put them here and store them as a vector using the concatenation function. So this will be our vector and we store it in a R object called temp and print it out. This is an unnamed vector, so if you look at the structure of temp, you can see it's a numeric vector of 5 elements, and we're going to create now a vector of weekdays, which is a character vector. And we're going to turn this, store this vector in a R object week. And now we're using week to name the temp vector. As you can see, the temp vector is unnamed up here. It's still unnamed. And we can name it by putting week into names of temp. Maybe to check the names of temp first. It's unnamed, so the names of temp is null. And we can put week into it. And then it will be named. It will be a character vector of names. If we now print the structure, I'm just going to do this here in a separate block. If we now print the structure here again, you can now see it's a named vector of numerical elements, and you can see that the additional, I'm going to print it out here as well. The additional values here, Monday through Friday, are attributes, and you can use these attributes in order to extract elements from the vector as well. So, for example, if you wanted to, I'm going to create another code block here. If you wanted to, you can extract, let's say, the first element using indices. So this is extraction by index. Or you can extract it by attribute. Extraction by name attribute. Or you can extract it like in the next exercise by using some logical vector. Yeah. So in the next one, we are asked to print temperatures from temp that are not below 80 degrees Fahrenheit. And this is something we do not want to do by hand. So we want to select using vectorization. So not below 80 degrees Fahrenheit means it's greater or equal 80 degrees Fahrenheit. So these are the question here is temperature greater or equal 80? And this question, is temp value greater or equal 80, is a Boolean or logical question. So the answer to that question is not numeric, but Boolean or logical. And here is the answer. You can actually store this vector temp 80 in a index vector, in another vector. Let's call it index. We could also give it a better name. For example, temp greater or equal 80. That's a more meaningful name. So we can store it and then print it. And you can check it's Boolean because the class is logical. And if you look at the structure of this vector, It's a named logical vector. Now the trick is we can use this Boolean structure as a logical flag vector. So we can use it as an index vector. I'm going to create another code block to show this again. And in the code block, we're going to store now, we're going to use this vector here, temp greater or equal than 80, as an index vector. So we're going to look for all the elements of temp. Here's the extraction operator, or the index operator, that have temp greater or equal 80. And this is the same thing as saying temp is temp greater equal 80, because that's where we stored the value before. And it's also the same thing as saying temp, actually let's leave it at that for now. Yeah, so these are two ways of doing that, of getting the value out. So there's only one temperature that is not below 80 degrees Fahrenheit. What I normally do is I use this as an index and actually call it index. So you can also go, let's say, index temp smaller, let's say smaller 80. That's another temperature range. And if I now print IDX, you can see that IDX is true for these values and false for the last one. So if I go and extract the elements with IDX, I get the first four. And this is something we're going to need later on as well. So let's get into a little bit of statistical function, in this case the average. So the average of the temperature of any vector is given with the mean function. So the mean function also vectorizes in the sense that it takes the entire vector as an argument and then computes the arithmetic average. And this works because temp has no missing values, as we will see below. Now, the next question is not to compute just the mean of all the values, but the average of the temperature for the week without the days on which the temperature was at least 80 degrees Fahrenheit. So without the fifth element in this case. And there are different ways to do this. We already have the IDX vector. So this vector here represents the days on which the temperature was below 80 degrees, below 80 degrees Fahrenheit. So saying this is like without the days of on which the temperature was at least 80 degrees Fahrenheit, that is the days when the temperature was below 80 degrees Fahrenheit. So one way is to use this IDX vector and then extract the elements numerically that correspond to these days and then take the mean value of them. And here it is, slightly lower because the 81 degrees on Friday are excluded. And there's another way of doing this, which we can get to in a moment. So for example, you can also, instead of reducing the values with a logical vector here, you can use the original one, which was temp greater or equal than 80. Actually, I'm going to make another block for that, because it's quite instructive. So we can look at the original selection turn that into another index vector or just use it as it is, and ask which days, for which days was this the case, for which of the elements was it the case, and you get number 5. Yeah? So this is a logical flag vector. The flags are being used to extract elements, and the which function, which takes a logical argument and returns an index, namely the number 5. And so if you put that together, you could now look at the elements of temp for which this condition does not hold. And you would do that by using the unary operator minus. And then take the mean of those. It gives you the same value. And of course, this is the same thing as which smaller. Okay, so this is a more complicated way of doing it, but which, however, uses the which function, which allows you now to compute with indices. Okay, let's get on. Create an unnamed vector. So far our vector is named, as you know. You remember temp is named. We want to make it unnamed. To make it unnamed, we're going to take the names vector and overwrite it with null. And if we do that, then name temp would be null. But we don't want to do that. We want to create a new vector. So we're going to create a copy, temp2, and put temp into it. And then override the names of temp2 with null. And take a look at that. And there we are. So this vector is named, and this one is not named. Yes, so the structure of temp2 is again simply a numerical vector. Now, we're going to do this, take this, and apply the matrix command. The task here is to take temp2 and turn it into a matrix. We do that with the matrix function. Yeah, so matrix function uses the values of temp2, and then we want a 1/5 matrix. So if we just do it this way, we get the default is that every element turns into its own row. So we can change that value in row to 1 and then get this kind of matrix. Yeah, so there's no difference to the values, but the object is now a matrix. Yeah, so if we save this in temp m and look at first of all, we're going to print it out again. Then we're going to look at the class of temp m. We no longer have a vector, we now have a matrix array. Or an array, special case is a 2-dimensional matrix. Well, our original object, temp2, was a numeric vector. Okay, so we've got a matrix, this one, and the matrix does not. The matrix columns don't have names. As you can see, each column is simply named by the column number, and it's notated in such a way that you can see that the matrix takes the matrix index operator takes 2 arguments. The first one for the row and the second one for the column. And if the space stays empty as here or here or here or here or here, it means that this is the column for all the rows below. Just like this 1 comma means this is row 1 for all the columns that follow. So to name our matrix, we're going to use the colnames function. Names of temp m, our matrix, should be null, and call names should also be null. So what we're going to do is we're going to put week into call names. Just like earlier we put week into names of temp, we're now putting week into column names of temp matrix. And then take a look at temp M again. And you can see they are now named. The printout doesn't really work very well. The Monday should be over the 76. So that's not ideal. I don't know if we can find a better way of printing this, but this is the way it is right now. If you look at the corresponding R buffer, you can see that here it looks better. Yeah. So if you print temp M here, you can see the printout is actually better. Okay, back to our job. We're almost done here. Now let's compute the average temperature without using the mean function. To do that, we can do two things. We can either add all the elements and divide them by the length of the row, or we could use a special function which is called row sums. So let's do both of these. Let's first do the pedestrian way, which is use temp underscore M 1, that's 76, and that's the same thing as 1, 1. 1, 1 gives you the name of the column, and if you leave that out, all you get is the element itself. Sorry, that did not work. Temp M, 1, like that. So that's the same thing. And we can now sum these up. I'm going to just write them. And I'm going to do this bit by bit here, comma 2. And since we, by default, if you do not specify the empty index, it is automatically assumed that you look at the first row. So we can just add these elements up because we have this special case of a one-row matrix. One, 2, 3, 4, and 5. We want to average of the entire matrix. Okay, first of all, that's the sum, and we average that by dividing by 5. So this is like the pedestrian method. Actually, there's a problem here because we have to, of course, put the sum together, and that's the average temperature. It's the same value we've received up here, somewhere up here. You can see it, mean temperature, same value. So that's the pedestrian way, by element. You can also use a function, which is row sums, and then you can just use the matrix itself. And then you can divide either by 5, or you can also divide by the length of temp M. So this is the more general expression. So this is by with function. All right, next one, compute the average temperature using the mean function. Now, you remember for the vector, this was simply mean applied to temp, and for the matrix, this works exactly the same way. It's still mean applied to temp matrix. So function works for matrix and vector equally. Even though, as we will see in a moment, that is not entirely true. There's some kink in this observation. So now we want to do the same thing. We want to reduce the number of elements to compute the mean. We're computing the mean only for the days where the temperature was greater or equal 80 degrees Fahrenheit. that is when the temperature was lower than 80 Fahrenheit. Same thing, or smaller. So we're going to do the same thing we did before. Mean. So let's build it up from the inside. You can build these things up from the outside. Start with the mean. We want to compute an average, but it's actually more. It's actually easier to build them up from the inside. So we begin by looking at the values that are smaller than 81, smaller than 80. That's the flag vector. And then we're going to take the matrix elements that correspond to this flag vector. And so for the time being, let's just for the time being write it all out. Which you should do as long as you don't really know these things very well. You should just keep writing things out and maybe not saving them. So this is extract with the flag vector as index vector. There we are. We have the values now. And then we're going to take the mean of all of that. And that's the value that we received earlier. Somewhere here, up here you can see it. Here. Okay, so that's it. Now I wanted to go a little bit more deeply into missing values. So there are three questions here about missing values. First of all, we want to add a row of missing values to the matrix. So we have this matrix now, temp2, temp m, and we want to attach to it a row of NAs. We can use the rbind function to that, row bind, and simply like that. So this is the result. And that looks good. So now we know we want to put it into a new object called temp m2. Run that and print it. And if we now compute the average temperature of temp m2 using mean, we get the same problems that we would get with a vector that contains an A. And we can try that if we just blindly apply mean to this new object. We get an A because there are NAs included and the computer cannot guess what the missing values might be. So you know what to do. The mean function works with the na.rm parameter, and you can remove these missing values and then you get the correct answer. Now this gets slightly more complicated when you want to look at subsets, as we have done before. So we're going to do the same thing now. Look for the average temperature for the days where the temperature was greater or equal 80 degrees Fahrenheit. That's the last value, actually not for the days when the temperature was lower than 80. That's really what we're interested in, because otherwise we only have one value and there's no point computing the average for one value. So we know this is Monday through Thursday. Okay, for this last one, we're going to use, let's check what IDX vector we have. So the IDX vector is correct. This is actually the temperature. We know that because when we look at the values, we can see the values, but these are mixed now with NAs. So if we simply blindly apply the mean function to temp to this object, mean of and then use the old trick, removing the NAs, we are in trouble. We do not get the right result, even though everything looks right. The result is actually 1 degree higher than the actual mean of the non-missing values. And the reason is that we have NAs mixed in it, and they cannot, because we have a matrix object, they cannot simply be removed the way we're used to removing them from a vector. So now we have to bring in some bigger guns. We have to bring in something called NA omit. There's actually a function called na.fail, which has a subfunction NA omit, which actually omits the NAs from the matrix but preserves the matrix structure. So let's check that out. NA omit is a function that takes the matrix as an argument, the matrix with the NAs. And you can see the result is the matrix without NAs with some extra information about the values that have been removed. So this is the argument that we're going to use for mean. But of course not the entire thing. We're going to, if we do that, we get 77.6 again. What we need to do is we need to reduce this by the last value. Oops, sorry, I made a mistake here. Yeah, that's it. That's what we want. Yeah, so removing the mean again, we first of all omit the values. So we use NA omit, which is a matrix, getting out the IDX values. Actually, is it a matrix or not? No, I'm a little insecure myself about the nature of this object. It's always fun that in these demonstrations at the end there is a question that I can't really solve. No, it's not a vector, so it's a matrix. I think that's what we'll find. Yep. So NA omit preserves the quality of being a matrix. And we have the values here, and now we can take the mean, and we do not need the NA remove function anymore. We get the right value. And that's it pretty much. So my recommendation is to use the empty file. I'm going to give the address here again. The empty file is at use the template for these questions to test your knowledge later after watching this video or even after seeing it in class. And the address for this is https:/vector popquiz. Thank you.